Hi guys, so today I'm just going to add on to our notes from yesterday. This is lesson 1, graphing absolute value functions. This is not due until Thursday, and it's a very simple lesson. So we learned yesterday about translations, up, down, left, and right of the parent function of the absolute value graph. And today we're just kind of doing a little bit more with that. So if you look at example 6, you'll see that you have basically two shifts that are going on. Remember, when you add inside of the absolute value, it's shifting you left or right. If it's positive, it's actually shifting you left. It's opposite of what you would expect. So this is going left 1 unit. And then the +5, if it's adding or subtracting outside of the absolute value bars, it's shifting you up or down. And positive is up and negative is down. So this is taking you up 5 units. So from the origin, from the center, you're counting left 1, up 5. So 1, and then 1, 2, 3, 4, 5 would take you to here. You look at the slope, which so far we've only done a slope of 1 because there's an invisible 1 in front here. So you just do a slope of 1 in both directions going upward. And that's how you graph absolute value functions. And you label the graph y equals absolute value of x plus 1 plus the 5. Pretty straightforward. Example 7 would just be a translation. And if you want to pause me and see if you could do it yourself, that would be a good idea. Actually, you have a little bit of a twist here. You have a negative outside of here. So this -2 is going to take you to the right 2. The +4 takes you up 4. And this negative is like in a quadratic function where you have a negative a value. It makes it open downward instead of opening up. So I'm going to first plot the vertex. I'm going to go right 2 and up 4. 1, 2, 3, 4. That takes me to here. And now the slope of 1, but going down. So instead of up 1, left 1, I'm going down 1, left 1, down 1, right 1. And my graph looks like this. And I label y equals negative absolute value of x minus 2 plus 4. So in example 8, now I'm changing the slope. So we have a 2 out here. That means my slope, instead of going up 1, right 1, is going to go up 2, right 1. My shift is still the same process. I have a +5 in here, so it's going to take me to the left 5. So I plot my vertex, left 5, 1, 2, 3, 4, 5. And this time my slope is going to be up 2, right 1, up 2, right 1, up 2, left 1, up 2, left 1. And so what you'll see is that your V shape becomes more narrow. So I have y equals 2 times the absolute value of x plus 5, and my V has become more narrow than it was before. So we have this new concept, which is very similar to quadratics, is when the absolute value of A becomes bigger. And again, I say absolute value because the negative just makes it open down. Your V shape will become more narrow. And that has a special name. It's called a vertical stretch. So if you think of a rubber band, if you took a rubber band and you stretched it up and down vertically, it would become more narrow. So that's a way to remember that. So now looking at example 9, same idea. You have a new slope, and you have a shift of right 1 unit, up 3 units. So I'm going right 1, going up 3, and you have this new slope here, which is going to be up 1 over 2, 1/2. So my vertex is at 1, 3, 1, 2, 3, and my slope is up 1 over 2, up 1 over 2, up 1 over 2. So you'll notice that the V is getting wider. This one's very wide. So again, just like quadratics, I'm just writing the equation on here. Just like quadratics, as the absolute value of A becomes smaller, then you end up with a wider V. And we have a name for that. That's called a vertical shrink when it gets wider. So think of like if you had like a cake and you took your hands and you smush the cake down, the cake would actually get wider. So it's a shrink. You're shrinking it down and it gets wider. Okay, to help you remember that. So looking at example 10, same idea. You have slope of 3, up 3 over 1, but it's negative. So that negative means it's going to be open downward. And you're shifting right 1. And you're shifting down 6. So I'm going right 1, down 1, 2, 3, 4, 5, 6. Just lost my place. Let's see if I can make this bigger. 1, 2, 3, 4, 5, 6 is over there. Try that again. 1, 2, 3, 4, 5, 6. And I guess I don't have much room to go open downward. So my slope is 3. So I'm going down 1, 2, 3 over 1. So all I can graph here would be this. Okay. If somebody asks you to describe the translation, here I would say it's a shift right 1 unit and down 6 units. It's also a vertical stretch because it's become more narrow because of the 3. And it's also, when it's open downward, you could say it's reflected in the x-axis. That makes it open down. Okay? So that's for like questions where they ask you to describe the transformation. And they're all pretty much like this. Okay? So this is not due till Thursday. Study for your test tomorrow.